Welcome everyone, and thank you for attending our webinar, How Data Infrastructure Improves Mill Analytics and Asset Performance. My name is Tom Terpel and I will be your moderator. Today our featured speaker is Mariana Sandin, Industry Principal with OSIsoft. Today's webinar will take roughly 45 minutes, followed by 10 to 15 minutes of Q&A. But before we get started, I'd like to mention a few housekeeping notes. First, this webinar is being recorded and we will be providing a recording and slides after the webinar. You can expect an email with the recording following the conclusion of this event. We will also be conducting a poll during the hour to better understand your recent experience with data infrastructure solutions and digital transformation. And finally, you'll notice on the right our Q&A option of the WebEx digital event platform. I want to encourage everyone to submit any questions you may have through this feature. If we're not able to get to everyone's question, we will certainly follow up with a response after the webinar. And with that, I'd like to now hand it off to Mariana to get started with today's presentation. Mariana, thank you for joining us.
Thank you, Tom, and thanks everyone for joining us this morning. Well, I'm in Houston, Texas, so it's still morning for me. I have people joining from all around. And just to get started, for those of you that do not know OSIsoft very well and what we do with the forest and paper products industry, I just wanted to give you a quick introduction of our footprint in this industry. So we have more than 400 deployments around the world. Among them are the top 10 companies for pulp and paper, and we've been working with pulp and paper for more than 30 years now. The PI system throughout this time has become critical for mill survival and transformation, and later on you will see some of the use cases that customers have been using solely the system or some of our partner solutions out there in the market. I would like to explain why the need of a data infrastructure versus having a simple data lake or maybe a bunch of Excel spreadsheets that handle data and that still seem to be working for your mill. And basically it's become because when we talk about data, and later on we're going to move into the analytics sphere of things, but when we talk about data, operational data that is critical for your day-to-day operations, we need to consider all the different aspects of this kind of information, from the new sensors that are becoming available in the market, smart devices that we are seeing, the management of all the history or all the data that we have in our current and older type of equipment. What happens when we want to make this information available at a plant level or maybe at an enterprise level. And as we move into more complex analytics, certainly need to share this information with probably a partner, a supplier, some of your clients, and most likely move things into the cloud so you can do complex analytics in a hybrid environment. So all these considerations need taken care of, and that's why we certainly need a data infrastructure to be able to take good value of the information available at the mills. So with that, I would like to ask you, what are the current initiatives or the current goals that you have for thinking of a data infrastructure? Here I am showing some of the initiatives or we are seeing customers and the way that they are applying the data infrastructure. But I'm curious from the audience, what is that you are thinking of or what you would like to focus on first? And you can choose more than one. I know some to each other, so feel free to select more than one if you have them. And Tom, if you may, in a couple of seconds, could you give us some preliminary results of the responses and what we're seeing? That's going to be interesting for the conversation later.
Certainly, Mariana. Yeah, at this time, you'll notice that the poll is open to the right of your WebEx digital event platform. Feel free to select any of the responses that definitely fit your use case. And we'll just wait a couple minutes here for everyone to answer the poll. But Mariana, based on conversations you've had with customers, where do you see most pulp and paper industries with their data infrastructure solution?
Yeah, well, certainly all the ones that you see here listed, but I think some of the low-hanging fruit, so to speak, has to do with operations monitoring, improving some of the processes. And I believe, I would say the second one is definitely asset reliability. So focusing on initiatives that have to do with maintenance and being able to, um, in a short way, do more with less, right? So having the parts ready, having streamlined the data flows and whatnot. It's some of the things that people will do at the beginning of their journey with the data infrastructure.
Okay. And we're just waiting for the poll to close now. All right, and it looks like more than half have chosen operations monitoring and asset reliability. So yeah, like you mentioned, Mariana, it looks like asset reliability is definitely one of the major factors. Well, everyone, thank you very much for your participation in our poll. Mariana, back to you.
Thank you. Thanks everyone for participating. And yeah, definitely this resonates because we know the situations at the mills. We know that we are operating with a very low margins of error, and little things that we can do to improve our performance and our production means a lot for corporations as a whole. So thanks for your answers. All right, so now let me get started really with how I came into the world of analytics and why is this important. So I was trying to understand why we sometimes we struggle with analyzing the data and what techniques can we use to make the data analysis simple. So, of course, I am an avid researching of topics that I have to solve, and I ended up reading about neuroscience. And with neuroscience, I read this book, The Organized Mind by Daniel Levitin, and in his book, he points out that when we start things, a new concept, the first thing we do is that we start organizing the data. And to organize the data, we create categories, priorities to make sense of the things that are around us. So if you can think of when you are when you're a young baby, and I have a young baby at home, so I'm also learning from him on this. So, but we start categorizing things by things that are edible and things that are not. In our world, that can mean, well, there are things that are critical events, there are some that are not critical events. And we start prioritizing these kinds of concepts. For example, a mill shutdown, it's a much greater event or much greater critical event than a paper break. Both consider downtime. So that is an overall category. And as we start doing this exercise, we also find out that our brain has limitations. So it has limitations in bandwidth, how many things we can be working at one time. And actually, um, in the book, this Dr. Daniel Levitin, he also argued that multitasking is really a myth, that we cannot multitask because our bandwidth is actually really small. We have about 120 bits of bandwidth of information that we can process. And talking to one person in particular takes half of that bandwidth. So really we can only keep a conversation with two people at a time. And if you're in an operator room, you have probably 3 or 4 screens that you're looking at. You have your colleagues right next to you. You probably have emails popping up. If phone on you and you're using it, you're probably sending text or using WhatsApp, whatever it is. So all these distractions limit our ability to really focus and find things important on a day. And at the same time, our brain, because of our evolution, is designed to switch focus from one to the other. And in the past, we did this because, it was a survival thing. Today, we do it because we have many different stimuli coming at us. Most of the time, if you are looking at it's going to be a pop-up email, it's going to be a notification, it's going to be probably something, an alarm blinking. And this switch of focus, although it is natural for us, it also depletes the fuel in the brain. So it consumes glucose that keeps us alert and awake. And there is no wonder that at the end of the time, we feel so exhausted after doing so many different tasks at the same time with a very limited bandwidth. So this is why we need analytics, because analytics at the end, it's going to help us manage the data in a way that it's going to give us a quick understanding of all the raw information that is available. Within these years at OSIsoft and working with several customers, found that the Gartner Analytics model is actually very um, insightful, and it works when it comes to applying or adopting analytics corporation. I believe it works because it is a progression. And as we start working with less complex analytics, at the end of the spectrum to the left, we have the descriptive analytics, and we start moving up towards prescriptive analytics, we get a better hang of the data, the tools that are available, and the value that each of these analytics are providing. So I think this model works pretty well in terms of, giving us a strategy for adoption. What I think this model is missing is the way that different tools are interacting with each other, because there is some overlap in some of those capabilities. So with data alone, we can have very good descriptive analytics, trends, seeing things historically. But once you start creating pivot tables or you put it in an Excel spreadsheet or using BI tools, you can have a better understanding of why things are happening, and you have more of a diagnostic analytic. To simulators and multilinear regression or even linear regressions, you start going into the predictive analytics. Um, and once you kind of merge everything together and you start learning things that you didn't know out of data models themselves, then you go into the prescriptive analytics. So I think these two models can give us an explanation of how things work together and how we progress from one level of analytic to the other. Now, but what have we learned from our customers in the pulp and paper industry? And some of these concepts have been presented by them and in some of our events at the users conference and whatnot. Probably some of you have been there already. So um, after this webinar, we can provide those references if you want them. But actually, this pyramid that I know doesn't look like a pyramid was presented by one of our customers this year. And in his presentation, I was really inspired by a new way to look at the analytics based on the lifespan of the applications that he was working on. So he said, well, if you have a throwaway short term kind of project, a kind of application, really what you're looking into when analyzing your data, you're looking at trends, tables, doing some ad hoc calculations, and that's enough. You can do it once, you don't have to replicate it, you can throw it away. And for example, a good example of this that he actually presented had to do with doing the analysis of a tank overflow. So this is a short-term analysis, doesn't happen very often. It's a throwaway kind of project. But if you're doing a recurring analysis of data on a schedule, let's say you want to do paper break analysis, um, maybe you are doing this by shift or at the end of the week or at the end of the month, whatever it is, you have to organize and create an application that is replicable and that has visuals and calculations that are meaningful to several people, to a bigger audience, right? So this is a more complex type of analytics, but it's those are events that can be somewhat easily captured and easily visualized. Now, if you're working with a business critical solution or business critical application like the energy consumption for the whole corporation at the end of the month, because this is going to be compared with the billing you get at the end of the month, then you need to look to a solution that is way more scalable, that is able to handle complex analytic from multiple and diverse data sources. And you have to have it visualized in a way that enables data-driven decisions. So this pyramid, although I know it doesn't look like a pyramid, also give us another way to look at how analytics play a role based on the applications or the solutions that we are trying to accomplish. So what I did is that I merged the analytics model from Gartner and the pyramid, and I came up with this progression um, in a butterfly. I decided to use a butterfly, but so first, what we're seeing with the descriptive analytics, when we're trying to understand what happened, well, yes, we do need trends, gauges, bars, some fix, probably some notifications. I know there are some engineers out there that cannot live without an Excel spreadsheet. So Excel spreadsheets are great when you want to do ad hoc analysis, maybe add some calculations right there, and maybe create some other charts. That's fine. One aspect that I think we also need to consider is data frequency that we are going to be analyzing. These kind of analytics will have near real-time inputs because you want to know what happened in the past and compare that to what's happening right now. When we move to the next level of analytics, the diagnostic, we want to know why are things happening, right? So we need to have accurate historical data, but we're probably going to do some aggregations. We're categorize things by events, and we're going to try to find patterns in that kind of data. Here we can do more advanced calculations in the data by using probably business intelligence tools, doing some linear regressions. In some cases, I've seen people using multivariate analysis. That's still valid, but I think that last tool, the multivariate analysis, it's mostly used when we're trying to predict what is going to happen next based on the data that we have in the past. Um, for this particular kind of analytics, the near real time information is not as important, but historical data, it's going to keep updating with real time inputs that are going to contribute to aggregations or to summaries of the data as we move forward. And in the prescriptive analytics, this is where, again, we are using the real-time inputs to aggregate the information, but here we enter into bidirectional communications. This is where we start closing the loop because we are asking data to tell us not only what's going to happen next, but um, how can we get the best results based on certain constraints? Maybe you want to have the best product based on the raw material, or the best product based on environmental conditions, and there has to be that closed loop with your systems, your actually process systems. And again, some of the tools will be machine learning, multivariate analysis, and simulators. So in the next slides, I'm going to use some actual use cases from our customers to exemplify each of these. All right, so we're going to start with the first use case, and this is the case of West Rock. And they decided to use the Pi system to create a descriptive analytics to make sense of the brown stock washers. So you can see very quickly that they first selected different stages or different levels of understanding the data based on users that we're going to have access to this information and the different KPIs that are relevant for each person. So what I really like about this is that they took the time to really think of the people that were going to be consuming this data and the data that they care about. So they are simplifying the different stimuli that these persons are going to be exposed to, helping them with those limitations that we talked at the beginning. Here are some examples of the different dashboards that they created. So you can see very simple green, yellow, red kind of signals to really point, in this case, the general manager to if things are not working properly. And they can see this very quickly just by a simple change of color. If we start drilling down into the information, now you see that more people have more access to information. Now, although for an untrained eye, this may look very busy, for some of the experienced engineers out there, they will have a better background on the information that they are looking for, and it's and a dashboard like this is more understandable. But still, we're trying to keep it simple. We're trying to keep it relevant to what they are trying to analyze. And at the end, the operators, they're going to be looking at things really in real time. And they want to know how historically, maybe in the last 8 hours and last shift compared to now they are operating, and gates and trends are great to do something like that. So now moving into the next kind of analytics of the diagnostic, we have the use case from Evergreen Packaging, and they decided to work on inline. So they had the issue with some of the winders at the end of the just before the start of the converting process. Um, where they had stock rolls. So basically, rolls that were on a line and that either had to be scrapped after they had been coated, or they had to be sold at a subprime price, which is not good. And this is how the thing works. So you have the coated roll, they have to go through the slitters, and then to the rewinders where you have the smaller the smaller rolls. And when it is stuck, it looks something like this. Here in the middle, you can see where the arrow is. It's not perfectly well aligned at the end of the roll, and this causes a problem for the customers that are going to be, or to the next step in the process, that are going to be cutting this this liner or this paper into the final product. So big problem for them at a particular point in time, with actually one of the most modern machines that they had available. So what they started to do was to analyze the data that was at hand, and they started seeing patterns, and they used some statistical analysis on them. And they discovered that the problem was that the operators were actually um, changing the set points in the machine, and they were not associated, they were not right according to the recipe that they had put together. When they found this, well, they found that there was an issue with the training programs of the operators, and bad practices passing by from one shift to the other, because there was not a training program in place. So what they did to solve the problem was first to create the visualization in front of the operators and the supervisors, where they had by product um, the set points of the machine, the way that it was working and running, but also the recipe information. With this, at the end of the day, they um, they would send a notification whenever there was a misalignment on the set points and the recipes based on tension, nip, and torque. And in 1 year, they were able to save $180,000 on product that was that was now meeting the quality expectations. So they were off quality product uh, by 60% in just this one machine. Because of this, this kind of analysis is actually replicable to other kinds of equipment throughout green packaging mill, but it could also replicate to other mills. Um, this is one of those more advanced analysis that can be done, and it can be replicated and put in a recurring schedule to prevent any other excursions that they may have. So again, it was a simple solution, but it was very effective at saving money and having um, better production numbers. Now, when we go to the predictive analytics, now we are trying to capture and target critical events that can mean um, really, really big losses at our mills. And this is a case of Klabin, the Puma site, so brand new greenfield mill that has been operating, I don't know, probably in the last 5 years, I believe, if that. Um, and they were having issues with their boiler, with their recovery boiler. So here is just an example of how they are tracking some of the critical events right from the data infrastructure tool that they are using. And this has to do with the digester. But one thing that they noticed was that with the boiler, they were seeing some faulty readings of high temperatures. This was something new because not all the boilers for Klabin had this problem, but this particular one that was the newer that just got into operations was having this problem. So working with the manufacturer, working with they were actually working with a partner that has some science background as well. They were able to find some of the variables that they needed to track and that they needed to notify on to prevent these kind of events from happening. Because the problem was when they had this faulty reading, then the mill would shut down. Right. So, if we pass certain temperature of the recovery boiler, this is a critical event and the mill doesn't shut down. And this causes not only the plant to stop, but you know what it means. And the Clubbing, it was $4.6 million, I believe, in losses every time they had this kind of event. And they already had one through a couple of them. So they were trying to prevent from this from happening again. And they do that. They start creating events. They create the notifications. They start notifying people. And at the end of the day, they noticed that they had about 6 different events that they analyzed. They actually um, prevented two of them. They stopped them because they put some workflows in place to let the operators know and to stop the shutdown procedures from happening. And they ended up saving almost $10 million by analyzing the data, by capturing the events, by notifying the right people about it. So, and this is only possible if you can predict based on the previous knowledge that you have in the data. Now, for prescriptive analytics, like I said before, the main difference is that we are trying to anticipate to things that we don't know or we don't fully understand the circumstances that create these critical points in time or these critical events. An example, I know that digester is a mysterious, complex equipment. It's the heart of the pulp mill, if you ask me. And maybe one of the things that we are trying to understand now is, well, what makes a furnace under the environmental circumstances that we have today will produce the best quality pulp, let's say in terms of brightness, right? So this question, being able to answer these questions, will have important repercussions in the way that you treat the pulp, the way you wash it, the way you bleach it, et cetera, et cetera. So another question that you may ask is, well, what is the forecast of the consumption of energy and water according to the schedule and the weather conditions? Today, is it summer? Is it spring? Does it make a difference? We don't know. So having a good question to answer is the first thing that you need to work on when we're talking about prescriptive analytics, because there are some unknowns, but we can try to have a more targeted scope when we are using this kind of analytics. Having a good question will give you several things. One is going to help to find alignment to the overall corporate strategy. And this will secure resources in terms of time, money, the engineers. It's going to help you find out if you actually need to partner with, let's say, a system integrator or another consulting company to work with the new tools and to understand better what data scientists or data science methods are available for you, and also to understand and track the value of the new models that you will be creating. That is very important. Have a good question that meets the criteria of alignment and strategy will give you the resources and the value that you're looking for. Now, the other rule is that we need to treat data properly. So with the first three kinds of analytics, certainly with the first two, it is easier to understand the data the way it is coming out of a time series database. But operational data and in a time series database, by default, by its nature, has a lot of things that can go, quote unquote, wrong with the data. You can have some gaps in the information, things can be out of range, um, different signals or different variables are being sampled in different timing sequences or different frequencies. So all this all these different factors make it really hard to transpose this information into tables, which is what most of these prescriptive analytic tools are going to be consuming. So there has to be mechanisms where you can aggregate and clean the data easily so that you don't waste a lot of time in this part of the process, because you're going to need it, but you don't want to spend too much time on this. So treat data properly, make sure that capturing the data and frequency that you need it, you can aggregate it, you can shape it in a way that these new tools can consume it quickly. Now, the rule number 3, involve your experts from the get-go. I know might be tempting to go to a consulting firm to tell them to solve the problems, that you know from your mail, but they cannot do this in a vacuum. Some of these tools can give us a very good accurate models of the control loops. You don't want to spend too much money and too much time on this. You want to be able to understand, one, the correlations that these tools are giving you, and to understand what the correlations mean, you have to involve your subject matter experts. So avoid surprise. Let your most experienced engineers be part of the projects, because they're going to be able to find some very good insights for your company much quicker than a data scientist working alone could. So here is one example of what prescriptive analytics may look like. And here I picked pattern recognition. And with pattern recognition, basically, we're giving the tool signals, and based on those signals, these tools will try to find bands of performance. And there might be some process of labeling that needs to happen at some point, and you will have the precursors, and maybe your subject matter expert will decide, well, this kind of event or this color of band mean that my pump needs maintenance, just as an example. So this is one actual use case from this is a mineral mill, but what they did was, and I'm going to be showing you some things here on the screen. So they recognized, after doing some pattern recognition, that this line at the bottom, whenever there was a high vibration, hours later, it would lead a problem in the process. So the whole process will get out of sync. It will start creating issues. In some cases, it could shut down the plant or the mill, and that's exactly what they were trying to avoid. So they knew that they could somewhat control the vibrations, but still these events were going to happen. The problem was, well, can we anticipate it earlier so that it doesn't end into the shutting down of the process? And so they built a model, and you can see here in the top trend, this is the current flow rate of the process right, of material coming into the mill. And based on the model that they created, this is the recommended flow rate or process rate that should be running at the moment. You can see there is a gap in time before the operator actually took action. So this is nudging the people that are actually running the process. And this is going to happen at the beginning, especially at the beginning when people are still trying to trust trust what the data is telling them. And happens very often when you have a certain set point, so a very high flow rate, and then you overcorrect and now you have a very low flow rate. But you can see as time goes by, the operator actually starts seeing that there is value in what the model is telling them and starts working more accordingly to the recommendations. So these are the kind of things that you achieve with pattern recognition, and these are the kind of behavior that you can expect from people working with new mathematical models that are telling them, um, that are predicting and prescribing how to run the processes. So additional use cases, I already talked about the pulp brightness, but equipment vibration that can be related, let's say, for water hammers at a dissolving pulp mill. You have the consumption forecast of water and electricity, and you guys can probably think of other use cases that I would love to hear if you want to add it into the Q&A. Um, the Q&A panel here in this WebEx presentation. So with that, I am ready to answer any questions or comments from the audience.
Thank you, Mariana. Folks, at this time, we'll be taking questions. Once again, please use the Q&A option to the right of your WebEx interface, and we'll answer your questions as they arrive. If you've happened to change your view to full screen, you may find the Q&A option now located at the bottom of your screen, so keep an eye out for that. And we do have a couple questions that have come in already, Mariana. Our first question, can you expand on the cleaning and transposing tools, particularly the lagging and aligning of the data? Rule number 2.
Sure. So you've probably heard from some of the analysts that this process alone can take anything from 30% of the time to 80% of the time. And OSIsoft, we actually found that the there are different mechanisms that you can extract the time series database, right? We have a thing called the integrators, the PI system integrators, that will help to create the views or the tables that you need to pass to the new mathematical tools or the advanced analytics tools, and they will take care of one, aggregating the data, but also lining up and finding those blank spaces that you may have in the operational information available in your history. I've also seen some other customers creating data streams that do the aggregation on the server side, and that this also helps with the performance and how you pass the information, because this advanced analytics will want a lot of information very quickly. So dealing with performance can also save you a lot of time if there are things that you can do to clean some of the data automatically on the server side by taking care of aggregations, exceptions, and compressions of the data, of the raw data from the get-go. So these are some of the techniques that I've seen, and it definitely saves time using the tools by being more, what should I say, being better at managing your raw data, but also by using the integration can save you 80 to 90% of the time, as one of our customers reported a couple of years ago.
Thank you, Mariana. Are those integrators done in real time?
There are two flavors of the integrators. One of them does things kind of offline, and the other one can stream data.
Thank you very much. Next question. What do I do if I'm stuck in a certain kind of analytics? We cannot seem to move forward from analysis data in the past.
Oh, okay. That is a good question. So I think probably the main reason of why that is happening is because we have missed the finding a good business challenge to solve, right? Certainly with a tool like Pi, when people have used it for so long, you have different groups of people using it for different purposes, but there may not be, or they may not have a common trend of a business challenge that they're trying to achieve as a whole, either at one particular side or at a region, let's say. So I would say, review the business challenge that you're trying to solve and find what is the better strategy to really solve that problem. It can mean your group with a multidisciplinary team. You may pull people um, from operations. You can people from maintenance. You can move in people from finance, right? And all can work together to put together a strategy and create at the next level kind of analytics.
Excellent. Our next question. In prescription analysis, do you have any example where the suggestion of change is replaced by an automatic order in the physical equipment, what's called PLC?
Yeah, I do not. As far as I know, we are working on right now, it's first trying to get a hold on having accurate models. So that is step number one. Step number two, when you have a model that is giving you an more accurate, not presentation of what's actually happening, I think companies as a whole are being conservative and they are notching the operators first. Because the operator at the end, it's they are working with the process day in and day out, and they have one in particular that's been this for the last 30 years. They know very well how the processes work, um, and they are getting the inputs from these models to make better decisions. But I have not seen one example of this loop being closed automatically. I would expect some of them will come soon, though.
Thank you, Mariana. Our next question, what Pi system tools can be used depending on the kind of analytics that I'm after?
That is a good question. And I actually, do we have backup slides? I believe they do. Okay, I had put together earlier, and I'm gonna cover it, but I decided not to at the end. But I guess this could answer that question. So in Pi system universe of tools that are available, I think there are definitely some overlaps and some tools can be used for several different things. So if you look at a product Pi Vision, which is a graphical representation of the data, like the examples that I show you with the use case from WestRock, I think Pi Vision is a tool for visualizing things that are ad hoc analysis that you're throw away, or maybe a type of support that you want to have in front of the general manager or in front of the supervisors all the time. And it can also be part of the business critical applications that you're going after, since it's a web application. So this information is going to be shared with the audience. So this is just some of the tools that I think fit well depending on the kind of solution that people can go after.
Excellent, thank you. Next question, is there ever a stage where the advancement in the model of analytics and data management replaced the human interaction with the information?
Ooh, that is a question, and I think if you're like me and you've been reading about this on social media and some analysts, I think there are mixed opinions and mixed data available for us to make a conclusion on that. Particularly, I don't think there is there is ever going to be a time where you won't have any human interaction in the processes. We're going to let the processes work with the data available to self-regulate and self-heal and self-produce. And the reason why I don't think that's going to happen, it's because there are so many exceptions in the pulp, especially the pulp and paper industries. The processes are so complex. The raw material that we work with is so complex. Um, the transformation that happens is so sophisticated that I think there are always going to be exceptions to the rule that the models will need to be always learning from. And that's where the human creativity and the human ingenuity come in, and that's why we need to have the best of both worlds, right? You need to have good engineers that understand data, but that also know to work with the tools that are giving them accurate information and more inputs to make better decisions.
Thank you, Mariana. Our next question, how do you move more quickly from descriptive analytics to prescriptive analytics?
Oh, that is a good question. And I think of a speed of implementation, you have to look at the resources that are available. There are many new disciplines of new graduates that are process engineers, but that also have data scientist um, training as part of the curriculum. I think taking advantage of the new talent that is available, it's a good way to do it. But pairing with people that have experience in the process will definitely accelerate things because, the young engineer from the experienced engineer, and they both can share the knowledge on the use of technology. So that is one way. And again, back to having a good understanding of the business challenge that they are trying to solve is definitely move with a better strategy.
Thank you, Mariana. Our next question, does OSIsoft help with services to help us transform the analytics we created in PE or process book, help them move forward with an asset framework?
That is a good question. There are several training programs and workshops that we can offer to help with that with that journey. But we also have a very big partner ecosystem that can help to alleviate that. I know for many customers that have been using Pi for 20 or 30 years, um, it's definitely a challenge and a different mindset to go from one thing to the other. But it is possible with a little bit of help and probably working with a partner is a good place to start.
Great, thank you. Our next question, what is the easiest type of equipment to scope for a prescriptive analytics project?
Well, I've seen a lot around the digesters. If I were to choose between types of digesters, I'd probably choose a batch digester instead of a K-mirror, just because a K-mirror is a continuous process. So that is probably one of the ones. The next one could be a paper, but that one is also a very continuous process with a lot of variables upstream and downstream. So I probably would start with a digester.
All right, thank you. Let's just see if we have any more questions. All right. Well, if there are no further questions, I'd like to thank everyone for attending today's demonstration. If you do happen to have any additional queries following today, please feel free to reach out to us from one of the follow-up emails sent out after the webinar. Once again, thank you for attending our session, and we hope you have a wonderful rest of your day. And Mariana, thank you so much for presenting this morning.
Not a problem. Thank you, Tom, and thank you everyone for joining me. Have a great day.
Take care.